We want to apply the fundamental theorem of calculus. Now, the fundamental theorem of calculus, how we apply it, is a little bit easier than the theory behind it. So let's practice applying the fundamental theorem of calculus. So here we have the curve 9x minus x cubed. So it's a cubic function, and we want to find the area between 0 and 3. So that area that we've shaded in here, that area is the area that we're looking for. We want this area in here. Okay, so what we're going to do is we're going to use the antiderivative, and the antiderivative's displacement should calculate that area. So we have this integral, this definite integral. We're going to anti-differentiate this. So when we anti-differentiate this, we're going to do this. So the area is equal to 9x squared over 2 minus x to the power 4 over 4. Using that antiderivative and the bounds, starting at 0 and 3, we're going to say that the displacement on this antiderivative function is going to give us the area underneath the curve, and vice versa is true. So when I plug it in, I'm going to end up with 81 over 2 minus 81 over 4 minus, when I plug in 0, I get 0. And so the area that I end up with is 81 over 4, which is equal to 20.25 units squared. So that represents the area underneath that curve between between 0 and 3, which happen to be the roots of that function. So this is how we apply the fundamental theorem of calculus. To find area, we anti-differentiate to get an antiderivative function, and we find the displacement, the difference between the points at the endpoints 0 and 3, and that will give us the area under that curve. So we'll do the same thing here if we just kind of sketch what this graph looks like. Okay, this graph looks like it has a bounce. So it has a bounce at 0, and it looks like it's going to come down like this and then up through 2. Okay, and between 2 and 3, we're looking for the area under here. Okay, to find that area then, what we're going to do is we're going to take the antiderivative function. So we're going to anti-differentiate this to x4 over 4 minus 2x cubed over 3. And the difference between the bounds, 2 and 3, the difference on the antiderivative should calculate the area underneath that curve. So plugging in, I get 81 over 4 minus, that's going to be 27 times 2, or 54 over 3. And then subtract the lower bound, we're going to end up with 16 over 4 minus, and this is going to end up being 16 over 3. Okay, so then I'm just going to subtract the common denominators first. I'm going to do this in 2 steps. So I'm going to end up with 65 over 4, and that's going to be 54 minus a negative, so it's going to be 38 over 3. Getting a common denominator, that's going to be 192 minus 4 times that is going to be 152. And that's all over the common denominator of 12. So we end up with 40 over 12, area, which is my area, which then simplifies to 10 over 3 units squared.